Hello, today we're going to be talking about lysimeters, what they are, how they work, and how to collect a sample from the lysimeter. Now a lysimeter is an instrument to be able to collect a sample of pore water from the unsaturated zone or the vadose zone. These are really helpful tools to be able to get a sample of the water as it moves or infiltrates through the unsaturated zone prior to reaching groundwater table. For sites that infiltrate stormwater, particularly industrial stormwater, these become a very valuable tool and resource to be able to monitor water quality prior to reaching groundwater table. Now, the lysimeter itself is then installed at various steps beneath your infiltration system. There are several different styles of lysimeters. In this video, we're going to be talking about what's called a stainless steel dual chamber lysimeter. It's about 2 inches in diameter, and it's primarily fabricated of 2 main chambers: a porous steel chamber to draw in water from the surrounding vadose zone, and then a collection chamber. This particular model, the collection chamber is about 540 milliliters total capacity, meaning for each draw of the lysimeter, you're only going to get out about 540 milliliters at most. You want to be mindful of that as you develop your monitoring program, because some analyses, depending on the lab, are going to require more volume of water, so you may require multiple draws of the lysimeter to be able to get sufficient volume.
You'll need the following equipment materials in preparation for sampling: a socket wrench with a 15/16 inch socket to open the well box cover, the vacuum hand pump, the pressure pump, 3 flexible neoprene tubes with clamps. These are the amber colored tubing with the white clamps. And your sampling equipment, including bottles, the cooler, gloves, and forms. Please contact us or your analytical laboratory to determine the minimum sample volume needed for each of the analyses. Here we are at an industrial facility with captures and pre-treats industrial stormwater runoff prior to infiltration. The lysimeter is installed approximately 60 feet below ground surface, and a well box has been constructed over the top of the lysimeter to protect the tubing. As you see, Blake opens the well box using a 15/16 inch socket. As a first step, we will inspect the tubing, connections, and well box for any signs of damage, such as worn or cut tubing. Make sure you never pull too tightly on the tubing, as it may detach from the lysimeter. Next, attach the flexible neoprene tubes with clamps to the ends of the 3 polyethylene tubes. Close the white clamps attached to the middle tube, that's the transparent fluid return line, and the shortest tube, the green rewetting tube. Keep the white clamp open on the pressure or vacuum line. That's the longest black tube. Next, attach the vacuum hand pump to the black tube and apply a vacuum between 30 and 40 kilopascals. The vacuum applied should not exceed 40 kilopascals. Inspect the gauge, the vacuum hand pump, to confirm the lysimeter is holding vacuum. A rapid drop could indicate that the lysimeter cannot hold vacuum, or that the porous steel has dried out and the lysimeter is only sucking in air. Once you observe the lysimeter is holding vacuum, you could close the clamp and disconnect the vacuum hand pump. The vacuum applied to the lysimeter will slowly drop as water is pulled into the lysimeter. Place the tubing into a clean Ziploc bag to keep the tubing protected. We are back, and we have let this lysimeter sit under vacuum of approximately 30 kilopascals for 6 hours. First, we will release the vacuum by opening the white clamp on the black tube. Then, open the white clamp attached to the transparent tube. Keep the clamp attached to the green tube closed. Next, while wearing new, clean, nitrile gloves, we'll collect the sample. Attach the pressure pump to the black tube and apply approximately 1.8 bars or 60 feet of pressure. The required pressure is a function of the depth of the lysimeter and will vary with each project where a lysimeter is installed. Water will come out of the transparent fluid return line. Collect the water from this tube into a prepared sample container. After the sample is collected, place the completed label on the sample bottle and place your sample within the cooler prepared with ice for shipment to the analytical laboratory. Lastly, remove the flexible tubes and place the caps back on the ends of the tubing. Place the tubing within a Ziploc bag to keep the ends clean. Then place the lid back onto the well box and secure the screws using the 15/16 inch socket to keep the lysimeter tubing protected. Thank you for watching. Please feel free to reach out to us if you have any questions.